So what is the Doppler effect? Give a definition. So the Doppler effect is this. It's when the heard pitch changes due to motion of objects. When objects are moving, there's a change in the sound that you're going to hear. Notice I said it's a change in the sound that you hear, not the change in the sound that's made. The same sound is made, but what you hear is not going to be the same. Okay? So let's explain the cause of the Doppler effect. So let's take a look at an example here. All right, here's an object that is just stationary and it's creating sound waves. And I'm going to clap every time the wave crosses the mouse. It's going to be like that every single time, no matter where I put the mouse. I can put the mouse to the left, I can put the mouse above, I can put the mouse wherever I wanted, and every single time the waves would happen at the same time. And that's because the object is at rest. But notice what happens if the object moves. Now it's going to change. See how that changed? As I go towards, notice that the waves are closer together than they were otherwise. So, what's the cause? The cause is when objects get closer together, the waves hit more often than they should. But when the objects get further apart, the objects hit less often than they should. So explain the cause of the Doppler effect. Okay. I'll put the rest of these online. You can get them from there. Yep. All right, so explain the cause of the Doppler effect. So as objects get closer, the waves happen, God bless you, more often than they should. But as objects get further apart, they happen less often. So, objects, as they get closer together, the frequency happens more often. As the objects get further apart, the frequency happens less often, which means the pitch goes down. So when the fire truck is getting closer, the pitch is higher than it should be. And when it gets further away, it's lower than it should be. That's the idea behind the Doppler effect. When the objects are closer together, the pitch goes up. When the objects are going apart, the pitch goes down. Okay, Give me some examples. Who can think of an example of where you've seen this before? Or, more importantly, heard it before? Yes. Yes, race cars. Welcome to Indianapolis. It is the best example that I can think of. Race cars at a track. Okay? If you've ever been to the race before, or if you've ever heard any of it on TV, you'll notice that the cars are going and they're like, right? Totally. That's a perfect example of it. But that's what's happening. That's the Doppler effect. The pitch of the frequency is higher than it should be as they go towards you. As they go away, the frequency is lower than it should be. Yes?
I was going to say tornado siren, but not sure.
No, that's not a bad one. The reason is when the siren is facing towards you, those waves are coming directly towards you. When it's facing away from you, they're bending around, and they're not going to be as often. That's a good one. So as the siren spins around, you get an increase or a decreased pitch. That's a good one. So the sirens, you can say fire sirens. You can use that example. You can use police sirens. We've talked about that one. We said the race cars. Sirens of any sort. Let's see, what were some of the other ones I said? Oh, train horns. Okay, when the train's blowing the whistle and it's like, okay, totally like that. That's another example of how they work, how the Doppler effect works. So train horns are another good example of them. All right, draw a diagram that helps explain the Doppler effect. I'm going to draw two diagrams that will help you see this. So the first one is that example I did on the screen. If you have an airplane that's flying forward, it's going to make these waves in front of it. But because it's going forward, those waves are happening more often than they should. But behind, they're happening less often than they should because you're moving away. So in front, you'll hear a higher pitch. And behind, you'll hear a lower pitch. All right. Any questions before I talk about one more thing, and then we'll do the equation? All right. I'm going to add like D.5. I'm going to add something here just so you can put off to the side misconceptions. So, things that people get wrong about the Doppler effect to be careful of. So, first of all, it does not affect volume. If it seemed like the fire engine got louder, that's only because it was closer. That has nothing to do with the Doppler effect. It's not because it's getting closer, it's because it is closer. I know that sounds like not a good distinction, but there is a difference. There's a difference between getting closer and that making a change and being closer and that being a louder sound. It's just because not as much of the sound is dying out in the air. That's the only thing. Okay? So it does not affect the volume. Doppler effect only affects the frequency. The other thing is the pitch before or after passing is constant. Here's what I mean by that. If this is the frequency over time, the frequency goes like this. It's a constant too high frequency, then it drops down to a constant too low frequency. it's not like this. It's not like the race cars are going around the track and they're going, they're not doing that. They're going around the track and they're going, they're doing that. So what happens is it's too high, 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 too high. And then it goes past you, and for a split second, it's Goldilocks. It's just right. And then it's too low after that. So it's that kind of a thing. Okay? It's not dropping something off of the building. Okay? It's an instant change. Not instant. It's a very quick change from high to low. Michael, can you put the phone up for me? Thank you. It's going from a high pitch too high to a low pitch that's too low. All right? Let's list the equation. We'll do the example, and I'll give you time to work on the homework, and we'll be in good shape. All right. Deep inhale, exhale, repeats. The equation is going to look terrifying. It is not, but it's not going to make sense until I explain it to you. So just write it down. Don't overthink it yet. Just worry about what's going on there.